the then if forward.
Welcome back, delegates. It was a great lunch. Hope you enjoyed it and made some new friends. But now it's back to knowledge building. Our first speaker for the afternoon session is from our partner association, Hanoi Association of Main Industries, or HAMI. He is the chairman of WellCom Industry Joint Stock Company and has been well experienced on machining or CNC and leader of several national projects related to CNC machine. Let's all welcome Professor Dr. Huang Bin Singh. A round of applause, please.
À, xin chào tất cả các bạn ờ, lấy hơi hồ một chút ạ. Vâng. Ờ, ờ, có lẽ là trước tiên thì tôi xin gửi lời cảm ơn ban tổ chức cũng như là các bạn đã có mặt ở đây để cho chúng tôi cũng có thể chia sẻ một số các cái giải pháp mà tôi cung cấp cho các cái ngành sản xuất. Nội dung chính ấy thì chính là introduce about the solution to measure and check quickly the electric vehicle smart machining and welding. Machining and welding is the two of the most popular method in order to make the part, especially in the car industry. First of all, I would like to introduce myself. My name is Huang Bin Singh. I'm professor at the Hanoi University of Science and Technology, and at this moment, I'm the deputy manager, general director of the Welcome Joint Stock Company. We are one of the top company to provide not only the equipment but also the solution, technology solution, and service after sale for many industry company and enterprise in Vietnam. We have the four sections. The first, introduce a little bit about our welcome. The number two is measurement problem in machining and welding, and our solution. And the last one is about the hardware requirement. The first, we would like to introduce very fast about our welcome company. We At this moment, we have about more than 1,300 nationwide agents, also including the franchise agent in Vietnam. We have about 25 showrooms and two service centers in northern and southern. And based on this one, and then you could see that we could provide to the customer our service to this customer very fast and high quality. And with us, we have the partner. The partner they provide to us the goods, technology, equipment, and so the service. Our customer almost at this moment almost the induction company and enterprise, some very big and high precision machinery in Vietnam, including the FEI company. Now I go to directly to the problem. During that's 2% almost the customer normal, especially about the manufacturer, they have the two problems. The first problem is when they order from their supplier, to provide the component. This morning, that's a presentation from Mr. Dong say about to improve the quality and how to management system. One of the problem that's when they order from the supplier and the part when we collect the part or component from the supplier almost very difficult to check, difficult to be sure that all the part is okay or not. That's very important. The second one is for mass production, when they produce some part or component and they do assembly together. Even, for example, in VinFast, there's many factory in VinFast, and each factory they produce their component and they combine together and they do assembly. But suddenly, wrong component, they cannot do assembly, and they move back to the factory and the origin factory, they don't know where problem is, and then this is a big trouble to check and to manage all the component. Here we are separated to be two. The first machining, the high precision machining is required a lot of process and to invest the equipment to check as how to say very expensive measurement equipment. Here the process is the first you can see yes to design and the design is a campaign software which generates the NC program and using CNC machine and we have the part. But the problem is after machining how to check. Uh, that's three normal at this moment the popular method to measure it is the first could use the hand. It's now it's about 90% of the supplier they use this one, and they also use some equipment, some method in order to measure on the CNC machine. And the last one, they could invest to buy the CMM machine. The CMM system is very high quality, high precision, and it's almost the investor they accept the design export from the CMM system. So now we can try to find. Of course, the manual measurement is okay, acceptable. However, it takes a long time, and the measure result almost according to the skill of the worker. We focus on two. The first on the machine, and the second using the CMM. Using the machine, I see when I come to the supplier, the manufacturer, they using the touch probe and they using the hand to touch to the measure the point. However, it's very take long time and make some broken problem. One of our customers, they talk every week they spend about 2 or 3 broken tool. And when they use the big problem is when the part is big and heavy, they cannot buy a very big CMM and they put on the good bit on the machine. This is the big trouble. And as you know, that's one thing that's almost a factory. They invest only 1 or 2 CMM machine, then it's overload when they their system, their machine system has problem and they have to measure continuously. Then it's overload. Uh, Here I use 2 examples. This is from Taco. This one is one of our customer, the big customer. They make the product for the Busan and their industry company. It's a very big one. That's nowhere, because there's no CMM machine, big CMM machine like that. About the 2 ton, 3 ton cannot. This is there's no way. And one of our customer talked to us as they lost some contract because they cannot show to the customer, their customers, the way they can control their quality. One of the problem is about the error. If you use a manual, even they use CNC and touch proper in order to measure it, include the theory error. Theory error, this is you can see, for example, here in order to measure this point, normal the worker put the proper here and go and touch here. Then you can see here always has this error. I try to calculate. I try to calculate, and this error, this is a theory error. This is very big. And the other method, they could move down here and move down the test proper, and then you could see here the error more bigger. Yeah, and you could see the error very. This is the theory. Theory. I mean, if you use this kind of method, you always your result, including those kind of error. Now our system we use the algorithm in order to test in the perpendicular of the measured surface. Then the error zero. This is our system. Uh, we're just thinking about the solution that we could use a CNC machine with a software, then it work as is a CMM machine. And you see the CNC big, and then they measure the big part. Yeah. Now we look around about the winding. Now the winding is almost at this moment almost the process set up like they use the teaching panel, and then they move the robot and winding and do something here. Then we have the many part and do assembly by winding process, and then they have it. But how to check it? Uh, at this moment, now you could see here they have the in order to check it, they have to create some zip checking feature in order to measure it. Okay, it's very complicated. It's very complicated, and also they have a solution. A solution they could use the laser scanning. They use laser scanning. However, it's not suitable for measuring. It's suitable for reverse engineering. Yeah. So we also think, oh, if we have the robot and if we have the software, then we can look like a CMM machine. In that case, everything will be okay and very beautiful. So we give a solution. It's called the LTS CMM system. For the machining. For the machining and the robot, we have the design, Web 3D design, and we create some measure point, and it automatically to generate the C code for CNC machine or robot program, and then robot program and CNC machine running. During the running is a software in order to collect data from the CNC or robot and then make the report. Very simple solution. Now, how we what are the advantage? The advantage. The first is automatically to generate the C code for CNC machine or the program for the robot, and especially from the CAD/CAM software. And also we have the software called 3D welcome design. This would ask a CAD/CAM software, the others CAD/CAM software compatible with them. And the second function is put simulation in order to check if some collision or not during the movement. Is this function very important? because as I talked before that, every week one customer they have to pay about two or three piece of the prober. It's quite expensive. It's about 100 million Vietnam đồng per piece. Uh, the the next is this our system would connect to the robot and CNC in order to collect the data. Uh, this function is also very useful as this morning presentation like about the Lean and Six Sigma. Also, this software could collect it, and after that it could make the many kind of the report, the parameter or information could create it. And for example, here you can see uh, the line, plane, cycle, or the distance, and many information. So this is introduce some user interface. It's very simple and very good. That's all could be in both language, Vietnamese and also English. Of course, if you would like to have another one, we could generate it. This is a very simple introduce. So we could import any 3D, and then we create set up the program, and then we apply, and we could select the point which useful for you, which you want to know essentially the dimension or the coordinate of the point, and after we can collect the based on the cloud of the point you measure it. You could generate about the cycle, about the center of the cycle, about the radius, about the concentric, about the parallel, and about the perpendicular, for example. Well, that's very simple. Yes. For example, here we would like, if you would like to know about the how to say the angle of the path, you could click this line and this line, and then you can find out the angle to between two lines. This is very simple process. Uh, this function we have many kind of function in order to measure. For example, if you would like to measure the planar of the plane, and also you would like to measure between two point two center of cycle, for example, it's easy. It's easy. Yeah, you could see collision. You could check the collision automatically to find out. Yes. Okay. So to the process to use it. Here, this is where I would like to show this is our software. This software could collect data from the CNC or robot and make the how to say make the report. This kind of report is one our customer. You could see here is the red line is out of the tolerance. Is the blue one, green one is inside is acceptable. And one of the things that our software could collect data automatically, and there's no operation for that because it is installed on the server computer. And especially about the mass production, our software could generate the CPK. Is necessary information in order to for the management manager to understand how the machining process in their workshop. Yeah, this is how to say. I would like to introduce our customer. Oh, yeah. For example, one is a very high precision part hormone. It's very big, part for the how to say in industry the structure, the steam structure system, and our software automatically is collects the data. This is our G code generate automatically our system. And here, this is our system to measure. To measure. For this one, I would like to how to say the apply, especially for the making the manufacturer, the car manufacturer, because in the car manufacturer there's a lot of robot, and the robot at this moment the process now after the punching, after the welding, after the machining process, almost 100%. They have to bring the part come to the QC room in order to measure by CMM machine. And the CMM machine is very big. And each time they measure only one part. Then if they use our system, they could check immediately after the welding, after the machining, even after the assembly. Uh, this uh, of course, at this moment they have the checking picture. However, after few months working, the checking picture some time and some problem because of the wearing and because of another many kind of the reason. Then the precision is really low. Yeah, you see. Uh, So the requirement about the hardware is very simple. For example, here, this is the CNC machine, the touch prober, almost they have this one. Almost the manufacturers they have both. That's only you by our software system and running automatically. For the robot, it's very simple. They have use the robot. We provide the laser sensor, and with our system, very simple. Then this is our presentation. I would like to, I'm very appreciative if some of you have any idea or any opinion for our solution, and I hope that this solution could become to the customer, especially about the manufacturer. I would like to talk that if almost the investor or the manufacturer, they have the problem when they collect the data, collect the part or component from their supplier, they cannot control the quality. But now with our system, they could require their supplier that in each part have the quickly checking report is very good and good save time, good save money, and of course happy. Thank you very much.
Thank you, Mr. Smith. Audience, do you have a question? Anyone? All right.
Hello. Okay. Thank you very much for very interesting presentation to see. Okay, I have some questions. The first one is your software is certified by any organization or according to any standard that is can apply for industry. This is the first question. The second question is when you are using measuring on the reactive machining, okay? So your software have a function for temperature compensation because it runs the temperature of accuracy. Okay, the third one, if you're using the CNC machine for measurement, okay, so that time the machine cannot work. So we set up this shift time. What I think is you can use another machine to measure and CNC is working. So I think it's I don't know, but it's optimization. So thank you.
Yeah, thank you for Mr. Bang question. It's a good question. The first about the certificate. The first, further on, I would like to share with you that almost assessment, even some the other system, they have no any, I don't know, for the purpose set up from the range, or they also have no certificate from the other system because it's a high precision. However, our system is qualified by Quates. It means they use our system and they use a CMM and they measure. They use our system measure a standard piece, measure piece. Then they use a CMM to measure it, and they compare the result and they submit to us. They agree to with us as accuracy. At this moment, according to the machine, according to the system, is our accuracy is about the 5 micron. The second one is about you asked me about the how to say the temperature, the calibration, or something like that. This our system using the calibrations processing. It means using the sphere and some the other process in order to compensate the result. Is acceptable because according to the ISO process. The last one is about after the machining and the CNC machine we use to measure it to take much more time than why we don't use another machine. Our system is very one of our advantages of our system is after machining they measure it and they decided to disassembly or continuous machining. I mean, after the machine, nobody know exactly what happened. The normal process is they take off the wood piece and bring to the CMM machine and try to measure it. And after measuring, it's some error, they bring back to the CNC machine, assembly, and measure continuous. And our system now is very simple. Just you put after the machining is because you know that our system uses Z code. Therefore, using the Z code to measure it. And after that, if on the dimension on the accuracy is enough in the requirement system already, requirement, how to say, the standard already, then they could decide to take up off. And after you take off, it means your workpiece is okay. You know exactly is okay. Uh, that's of course, for mass production, our system will increase the second half, increase in the second half. However, it's according how to say it's based on the machining processing that if you estimate, for example, you receive the order from Toyota require you, they will check on the part you transfer to them, and they for example you ship to about 1,000 pieces, and Toyota QC they take 5 pieces and they measure it. If they measure it one of dimension error MC, they reject all the 1,000. Normal like that. Now you could rethinking that. If you increase the second hand a little, but you could manage your quality of the copy. This according to the how to say your system. Of course, you could buy more machine, or you could how to say you could discuss with your customer about that. Thank you.
When my name is I come from Vietnam Saturday. We are dealer of Dosan tool in Vietnam. Yeah, I have some question for you, so I will ask you by Vietnamese. Okay.
Vâng.
Em hỏi anh một chút là em rất là ấn tượng với cái giải pháp của bên mình và em có một số câu hỏi liên quan đến máy CNC. Thì như anh cũng biết là trên thị trường rất nhiều hãng máy CNC nó kết hợp với nhiều bộ phận khác nhau, và Nakisu hay là hai hoặc là Masato hoặc là Professional. Thì cái phần mềm của anh khi mà tích hợp vào cái cách game ấy, thì có sự lựa chọn các bộ điều khiển dành cho máy CNC hay không? Đây là câu hỏi đầu tiên. Thì macro hoặc là input sẽ có cái một số cái điểm nó khác nhau của các bộ điều khiển. Thì em hỏi là có sự lựa chọn về bộ điều khiển trên cái tập thể khoán hay không? Cái thứ hai nữa là nhưng mà CNC kết hợp với hệ thống measurement ví dụ như ONP hay IFP của ISO hoặc là Mascot thì có sự khác biệt gì khi mình lựa chọn những cái đó hay không? Và câu hỏi thứ ba em cũng được anh có thể là chia sẻ cái chi phí mà của cái phần mềm này nếu như đến đây sử dụng estimate.
Dạ. Cảm ơn bạn, rất là vui ạ. Và cũng xin phép chia sẻ với bạn một chút là hệ thống này đang chạy rất tốt cho với máy Dusan này. Chạy rất tốt cho máy Dusan, hiện giờ có các khách hàng đang sử dụng rồi đấy ạ. Vâng, chạy rất tốt. Câu hỏi của anh rất là tốt. Thứ nhất là có phụ thuộc vào bộ điều khiển không? Có. Và tại thời điểm hiện nay thì hầu như tất cả các cái dạng máy đều cũng đã được thử nghiệm, ngoại trừ có một cái đó là 2 và Okuma thì chưa, còn hầu hết đã có thể là tích hợp được rồi. Thì đấy là quảng cáo như vậy. Thứ hai là nó cũng phụ thuộc vào các cái đầu đo không, thì cũng không cũng rất là may mắn là tất cả các loại đầu đo từ Macros cho đến Renishaw cho đến các đầu dò của Trung Quốc, tất cả các đầu dò và cả Bloom nữa thì hiện giờ là đều đã đang chạy được hết rồi. Và nó sẽ có một cái khái niệm tức là cái liên quan đến cái chương trình macro thì vì hệ thống này sử dụng các chương trình macro là có ISO, tức là không sử dụng bất kỳ một cái hệ cái macro đặc trưng nào hết cả. Ví dụ không phải chỉ riêng của Fanuc, không phải riêng của Mitsubishi cũng chẳng riêng của Siemens, mà đây sử dụng là của ISO, cho nên chính vì vậy là nó compatible với toàn bộ. Vâng, thì đấy là thế. Còn về giá thì ở đây thì nữa thì chắc là cũng mời anh ở đây có bạn Tú về những phát triển ngành hàng thì anh có thể hỏi, nhưng mà nó thực sự rất rẻ hơn anh nghĩ rất là nhiều ạ. Vâng, một giải pháp cực kỳ rẻ và tôi nghĩ rằng là chắc là anh sẽ dân mình thôi. Và cái này thì tí nữa thì gặp bạn Tú ở đây thì bạn ấy sẽ phối kết hợp ạ. Ở đây thì có rất nhiều một số các bạn về kỹ thuật của Wencom.
Thank you, Mr. Sin. If you have more questions, feel free to approach Mr. Sin. I'm sure he'll be happy to answer all your questions. Thank you, Mr. Sin. Before our a round of applause, please. Before our next
Cảm ơn anh rất là.
Before our next speaker, I have a reminder. Tomorrow we will have a factory tour at AHPM Vietnam. So the registration will be on a first come, first served basis. So for those of you who are interested, please go to the registration booth and give your names. Okay. Our next speaker is from Belfast, who has more than 13 years of experience in the automotive industry, leading a team of 120 engineers across the globe and manage the EPQP and supplier management for all purchase parts for EV cars, e-scooters, and e-buses. He will discuss about the advanced supplier quality approach for efficient quality control. Let's hear it from Mr. Pravin Dorairajan Prakash. A round of applause, please.
Okay, good afternoon, team. Thanks for taking your time to listen to this presentation. So, as I said, as the topic says, it's about advanced supplier quality approach for efficient quality control. And in the previous presentation, Dr. Sin was touching on the problem where we don't know whether a supplier is actually giving us good parts or not. And one of the solutions that he gave was on using automatic measurement techniques that's closed looped with your machines so that you get your feedback then and there. So that's probably applicable for a specific set of machines and a specific group of components. But the presentation that I'm going to be taking forward the team through is more on overall approach and strategy and how companies and OEMs could think different in terms of approaching the supplier quality. So let's look. Okay. So before getting into the presentation, just a disclaimer, all the thoughts and the views expressed in this presentation are explicit of myself and nothing to represent the company, Winfast, or the group or its affiliates that I'm associated with. Okay. So there could be some disagreements in the contents that I'm putting forward in the presentation. In that case, please get back to me directly and I would be able to and happy to answer it. So it's here. So just a quick introduction about me. I think Dee gave a good round of introduction, so I'm not touching on the slide. It's available in the SharePoint deck. You can have a look at it. So next. So before we start actually getting into the topic, so whenever I think of quality, as a quality person, whenever I think of quality, there are two events that come to my mind, and I keep articulating this in multiple LinkedIn posts that I write on a weekly basis, or even to my own team members. So the first event is about. Okay, so this is the famous Space Shuttle Challenger liftoff back in 1986 that exploded 73 seconds after takeoff. So, anybody in this room have an idea of why this disaster happened, or why am I linking this to quality? Okay, so here it is. So this is basically the Challenger construction. So this is the liquid hydrogen fuel tank, and then you got these two white items called the boosters. So basically, what happened is there are two O-rings between the booster and the liquid fuel hydrogen tank. One of the O-rings was of a much poor quality, which allowed the gas to escape through, and within 73 seconds of takeoff, the shuttle burst, killing all the 7 crew members. And this was one of the most fatal crashes of NASA. So, based on this, my lessons learned is any mistake that we make on design or process quality will affect the end user. Anything that affects the end user is going to affect the organization. It can be the OEM, it can be the supplier, it can be anybody in the supply chain. Anything that affects organization will finally affect us, which means the employees, the people who are associated with the organization. So essentially, it's kind of a boomerang reaction that happens. So first thing, we have to do the right thing always. When we talk about quality, it's always about doing the right thing. The second event that comes to my mind is the Concorde crash that killed 113 people, the one and only fatal incident in the history of Concorde that put an end to the Concorde history. So this was in July 2000, Air France flight 4590. It was a passenger jet on a charter flight that crashed shortly after takeoff. So let's have a look at what exactly happened. So this is a pictorial representation of what happened. So the Concorde suffers a tire blowout on takeoff. There are long flames coming from the undercarriage that is represented by this orange here. And then the nose rises and the plane stalls. For anybody who is following air crash investigation, you know that the more the nose rises, higher is the chance of the plane getting stalled. And the moment the plane reaches the stall altitude, then that's it. It will tumble and just crash wherever it is. And in this case, it crashed into a place called the Gonesse. And why am I again linking this to quality? Why am I talking about quality here? If we have to know why this first cause happened, tire blowout on takeoff, we have to go maybe 5 minutes prior on this. So on the same runway that the Air France took off, there was a DC-10 Continental flight that took off, and during takeoff, from the engine, there was a metal, you can call it a small metal piece that got deposited on the runway or just got dropped on the runway. And this metal piece is what hit the tire of the Concorde. And then that's what led to the air crash and the infamous fatal crash of 113 people dying on board without even knowing why they died. So this is what exactly happened when you look at the sequence of events. The flight is cruising at 323 km per hour or about 190 miles per hour, and the tire hits a metal strip. Tire explodes. The exploded tire hits the wing. The wing, okay, in Concorde is the only flight in the world that has got fuel tanks on its wings. All the other flights have fuel tank on its bellies. Concorde has fuel tanks on its wings. So when the tire hit the wing, the fuel tank gets dynamically shaken, leading to an internal fuel leak, fire, and explosion. So if you look at the sequence of events, the one at the green, okay, that's a man-made, a pilot is driving it. But this red one, you know why a metal strip came into this place? The metal strip fell from the engine of the Continental that had taken from runway 5 minutes previously, and this strip gave away due to poor workmanship and non-standard process that was done on the DC-10 flight at its hangar, or in other words, called the workshop, where you just repair the planes for small repairs. So my lessons learned is quality of event in every work we do is needed. It's not an option; it's a mandate. Our lethargic and irresponsible nature could prove fatal to someone else across the globe. Like this engineer who was using that strip on the engine workshop was so careless in his nature, which finally affected 113 people on board. So, quality is a topic that has to be taken seriously by everyone associated with manufacturing. So, that's the reason these two events always kind of strike me whenever I look about or think about quality. So now let's get into the real stuff of the presentation. So when we talk about quality in OEM, as I'm from an OEM, first I'll touch one or two things on OEM and then let's get into the organization standpoints. So there are different kinds of quality in OEM or different verticals into which quality is integrated. One is the development quality, manufacturing quality, vendor quality or the supplier quality, service quality, quality control, and quality assurance. So today, going forward, we'll be focusing only on vendor quality or supplier quality. But supplier quality, two terms. So before we get into supplier quality, suppliers have to do this, supplier have to do this, everything, putting the onus, everything on suppliers. But let try to understand what suppliers are and how they are important to the business. Supplier is nothing but extension of our business. That's the first thing that we have to take in mind. Be it an OEM or be it or any organization, we got to consider suppliers as an extension of our business. Most importantly, we are dependent on suppliers' expertise, both on product and process. Suppliers should be treated as equal partners in business. There cannot be a point that I am the organization who is giving business to you, so you are a supplier. You are bound to listen to whatever I am giving you. Never that way. Business not works that way. So they have to be equal partners. Okay, now the word quality. So here are some of the definitions from the famous quality gurus from Joseph M. Juran, Mr. Crosby, the ISO 9000, and something from the IATF handbook. But the last definition is what that I love the most. Quality is doing it right when no one is looking. So it's not about just fitness for use. It's not about conforming to anything. It's about doing the right thing even when there is no one looking. So it's like if I'm an operator who is producing a part, and as per the SOP, if I'm bound to check the part, whether my supervisor is looking over my shoulders or not, I should still be doing the right thing. So that's more important. So putting these two together, supply quality means nothing but equal partners in business whom we are dependent for the success. That's again demonstrated based on fitness for use. And in any organization, be it OEM or Tier 1, supplier quality plays a key role in supply chain. and also determines the value of the purchasing cost spent by an organization. As I can see many purchasing colleagues and many managing directors sitting here, I'm sure when the moment you talk about purchasing, the first thing that comes to your mind is cost. And as a purchaser, these would be the business requirements to, or the famous 5 R's, right supplier, right time, right cost, right quantity, and right quality. And today we'll be focusing more on quality, the right quality. So this is the famous quality continuum flowchart where everything starts with inspection, then we move to quality control, and then we move to quality assurance and business excellence. And there are very, very few OEMs or tier one organizations in today's world that have achieved this level, business excellence. There are a lot of organizations moving towards quality assurance, but the majority of the population is focused on inspection and quality control because we have new designs, we have new markets, time to market is slow, you don't have time to establish systems, so you gotta get things done on the way. So that's where I'm gonna talk about specifically today in between quality control and quality assurance. So that's what I call as advanced quality control. So before we get into advanced quality control, let's try to understand what does quality control mean. So quality control basically is on two verticals. One is your product control, which is basically your dimensional checks. You check with the vernier caliper, CMM, checking fixture, gauges, whatever it may be. And second is your process control, which is basically your 4M: man, machine, method, and material. So for materials, you do have your mil TC and lab checks. For man, you have your on-the-job training and the skill matrix. And then for machine, it's your daily check, preventive maintenance, Jishu hose and check sheet, or whatever name, but it's all part of the same thing. Method is your control plan, SOS, and JES. So this is standard quality control approach that's followed across the world, irrespective of any supplier or any OEM it is. But when we talk about advanced quality control, what it is actually, it's about in product control, it's about adding something called as a quality firewall. So let me talk about this firewall in the upcoming slides. And in process, it's not something new apart from what we are doing. It's your process audits. So when we talk about quality firewall, it's 100% inspection, but not of all characteristics. Every product will have three characteristics. First is your safety, second is your functional, third is your fitment. As long as 100% of the product is being inspected for this, you will be sure that your process is streamlined and capable enough to give delivered quality at given point in time. It is a stage that is separate from final inspection. And the characteristics are signed between organization and supplier. The most important point with the quality firewall is any issues at quality firewall, it's a early indicator of the product quality issues. So if I'm finding something in my quality firewall, it's an indicator that it's gonna hit my line at some point in time. May not hit today, but it's going to hit at some point in time. So it's kind of an proactive warning that something wrong is going off in the process, and I will have to step in to correct it even before the actual issue happens. On the process audits, there are three major process audits that I would like to touch upon here. One is your control plan audit, which is often called as PCPA in the industry. So it talks about sufficiency and compliance. So sufficiency is I have a control plan. Whether that control plan is sufficient for me to get 100% repeatable products at a given quality. That's sufficiency. Second one is compliance. So as the name suggests, whether am I complying to what's written down in the process. Most organizations fail because our control plan is not sufficient. In manufacturing industry today, especially in auto manufacturing, many suppliers have become compliant to the control plan. So I just take the control plan, do an audit, I find 9 out of 10 suppliers are following the control plan. But if I put one step ahead, is their control plan really sufficient? I am doing a patrol inspection of 1 in 5 pieces for every, say, every 3 hours. Is that really sufficient to control the process? Is there a statistical backing behind why am I selecting a control? So that's where this control plan audit will help us to understand the sufficiency of a given controls that's being put in place. Second is your special process audits or the CQA audits. So basically, I've got 9 CQA audits that's prescribed by AAG. Almost every one of us will be very familiar with CQI 9, which is for heat treatment. But apart from that, there are 8 other audits for 8 special processes. The reason why this is called a special process is every process here, it's like making a bread. It's like putting inside an oven. So you can only control the input parameters and the output parameters are always fixed. So the reason why it is special processes, unlike machining, where you can control at given point in time, for process like brazing, casting, any of the 9 processes listed here, you cannot control the quality of a product once the process is started. So it's what you set. So that's why it's called a special process. And this is really key to identify issues upfront, the systematic as well as the technical issues. Third one is the poison testing process. This is basically under a controlled environment, you intentionally give across a red sample into a batch of green parts to see if your measurement system is able to detect it. When I say measurement system, it's logically called the swipe system, where it's called the standard, workpiece, environment, instrument, and person. So whether all this put together is able to identify this red piece or not. So that's what poison testing process is about. So finally, between an organization and a supplier, transparency in terms of open sharing of information in all quality matters is needed. Be it Tier 1 or be it OEM or be it Tier 2, this transparency is must needed in today's business scenario because everybody is moving fast. We don't have time to go and check whether whatever a supplier is telling is really right or wrong. Second thing, does not matter who is wrong. The right thing must be known to both the parties. Working towards a common goal, which is quality and customer satisfaction. Once quality is set, business automatically grows. So far, I have been touching overall as an organization and a supplier. Over the next 3, 4 slides, which is towards the end of my presentation, I would like to touch upon specifically what is important for from an OEM standpoint. So OEM, as you all know, is the original equipment manufacturer. So I have worked in multiple OEMs and trying to put out my views here in advanced quality approach. So automotive industry, when I look between the past, present, and future, past is all the combustion engine cars, present is all about transition into EV, future is going to be EV and hybrid. So when I look at ICE versus EV or the combustion engine versus the electric vehicles, the supplier base and the component type. In an ICE engine, I have conventional suppliers. When I say conventional suppliers, suppliers who are long standing in the field. They are like 30 years, 40 years, 50 years experience in the field, and they have been doing the same product over and again. And most of them are mechanical components. But when it comes to the EV car segment, the suppliers are technology based suppliers. Every supplier has got something unique to offer. And than mechanical, there are a lot of electronic and mechatronic components. So this is where the challenge really comes for a OEM in controlling the suppliers. So this is just a picture of today's car. This is actually an ICE car, but even in an ICE car, you have this many number of electronic modules. So average any car that you take, it's no longer a mechanical device. It's an electronics on wheels. And Average 45 electronic control units are present in today's EVs. And today's car is nothing but a supercomputer that's connected with multiple computers inside. So rather than telling them as car, the right technical word would be software defined vehicles. There are two major challenges. One, as I said, is technology based suppliers. Integrating them into the auto domain. That's first key challenge. Second is the most common thing ever since the COVID struck us, the global chip shortage, leading to a whole lot of spot buys, people craving around to get chips from wherever it is available. So for the technology-based suppliers, OEMs are highly dependent on technology-based supplier performance in terms of design and quality, because OEM has zero idea of what technology, the what do you call the patented technology the supplier is offering. It's only about the integration that OEM is responsible for. As a FSS, they are responsible for the design. Mostly software providers and software-based components, nothing but the ECUs. And majority of the softwares today are safety-centric, no longer comfort-oriented or infotainment-oriented. We have a lot of safety-centric softwares, like braking softwares, your vehicle control unit, it's a safety-centric software. So OEMs today are working on, including the company which I represent, we're working on software APQP. All we know is about hardware APQP, which is basically going through the 5 phases for hardware development. But OEMs have now got into something called as software APQP, custom tailored or custom suited A-Spice audits, which is to meet the challenging timing targets, regression testing with quality assurance testers at OEM's cost. So a supplier sends a software to OEM, no OEM directly just puts it on the vehicle. They do a whole lot of rigorous testing, just like an IT industry between a developer and a tester, how they do checking the softwares. The same kind of testings happen in auto industry today. Software confirmation check sheet has been integrated into PPAP, back checks, and yearly validations. On top of following all this, incoming checks on software levels checks prior to vehicle point of fail. If you take WinFast, every ECU that is coming into WinFast with a software loaded onto it goes through a 100% pre-fitment software level confirmations. Your hardware, bootloaders, whatever software terms that you talk about, everything gets checked at the or prior to the point of fail. So the next challenge, the last challenge, is the global chip shortage. Semiconductors, a survey says there is a 11.9 percentage of compounded annual growth rate between 2022 and 2028, specifically on auto industries. And with the rising chip prices, an average OEM today spending about 540 US dollars per car is going to spend about 910 US dollars per car. This is just on the components, not on the integration standpoint. Chip scarcity is on the rise, leading to inevitable spot buys. I'm sure every one of you here know what a spot buy is. At the same time, quality is important as chips are malleable. Malleable means something that's very fragile, something that's very volatile. When you don't store your chip properly at temperatures under 25 degrees, the chips don't intend as function. So all these account for the malleability. So what today's OEMs are doing? Number one, they do a whole lot of extensive in-house validation for the spot buys. No spot buy chips are just like that taken on the vehicle. Introducing agile development with multiple cross paths so that in the event of shortage, one chip can be substituted for other without impact to the customer. And this is a key point which today's OEMs are following, where right from development, generally you take a hardware component. When we develop a component, we fix three materials for one component and just go ahead with the development. But here, when I have a chip from, say, Nexperia, I do one level of sample, and then the same alternate chip I try to source from Samsung, or try to source from some other like TI or NI, and I build another sample with it, and I do similar level of product validation simultaneously during product development, so that in the event of a global shortage that may happen, I wouldn't have to work on this in-house validation once again because I already have the test results, whether it works or not. So it's kind of giving more options. And aggressive incoming quality checks with jig-based testing. This is like any other electronic industry does. And this is another thing. Although we do agile development, despite in-house validation, there is a component and a vehicle level aging checks to double confirm chip functions as intended. So aging check is basically we power on the unit for an extended amount of time to ensure it functions as intended. So with this, I think I've come to the end of my presentation. So any questions, I would be happy to answer. Oh, Dr. Singh.
Thank you very much. Your presentation is very impressive. Suddenly I feel it's very surprised. And of course, I just wish that the organization your presentation should be first, and the presentation the second, and my presentation the third. It would make to all the person here, all the education here would understand deeply. Thank you very much. I would like to ask you if we have the occasion to talk to you, and we have how to say the opportunity to work with you about this one because in your presentation about there's many points in your presentation with our software, and also especially we also this afternoon in the lunch we also discussed about the fees from the ODMs or the supplier for the quality control. I think it's a very good one, and I would like to ask you if we have opportunity to cooperation with you.
Sure, Dr. Sen, not a problem at all. Let's catch up sometime after this and let's see how we can help each other. Sure. You have a question?
Okay.
Thank you so much for the organization. I quite enjoyed the topic today. So, I saw about the global chip shortage. So, I just one question for you because we work for the request. I just wonder, so how could you deal with the shortage problem for the VinFast? So, chip shortage problem in VinFast. Because there are others.
It's like firefighting. It's like firefighting. So it's never ending. Ever since COVID started, this chip shortage has been on the rise. It was expected that somewhere around 2023, the situation would settle and we all would get back to normal business, but it's not the case. Like in the last 5 years, the entire industry has taken more than it could consume, and now we are in shortage across the globe everywhere. So WinFast specifically, we do have daily challenges in meeting our own chip requirements. As you know, WinFast, we are vertically integrated. We do a lot of electronics in-house. We manufacture our own display screens that you see on our cars, the gateways, many of the 5-in-1 or the 3-in-1 inverters that's there on our cars are all in-house made. And every one of these electronic items need a whole lot of chips to be done. And of course, the reason why I touched on the global chip shortage is because I am one of the person who is deeply affected by it. So that's all these over the last 2 years, whatever the last slide that I mentioned here, are all about what we have done differently in WinFast to cater to this rising shortages. At the same time, customer demands to get the cars to the market as soon as possible.
So one more thing, sir. You have mentioned about the agile developments. Actually, so I have some research about the agile development for the semiconductor industries.
Mm-hmm.
So nowadays, it's quite, I think agile trend to develop the chip integrated service or something like that. So I hope that I have the opportunity to discuss more detail with you in
Yeah.
deeply understanding about it.
Sure. I think I can connect you with my design head of EE so that you can put forward the solutions that you have in terms of agility.
Thank you so much.
Okay. Thank you.
Oh, there's two more. By the way, guys, we will have a cocktail party at 5:30 p.m. So if you have time, you may stay at 5:30.
Thank you for the vision. It's a very nice vision. Learn of the vision. I would like to ask, why is one of those clients who said that the chief security is on the rise? But what does it mean rise? Rise is not related when you write time from.
Okay.
My second question is the human resource for chief, which is if you have what should be there for that. Can you give us some tips or some advice?
Okay. So first question, chip scarcity on the rise. So when I mentioned that, what I meant is chip shortage is constantly increasing. Like last year, I didn't have say 1 out of 10 chips that I need. Today, I don't have 5 out of 10 chips that I don't need. So that means I'm kind of having this shortage constantly increasing. My red bars are constantly increasing. That's first thing. Second thing, with respect to the human resource for the chip industry, apologies, I'm not a qualified person to comment on the human resource for chip industries because it's way out of my current scope and competence. So sorry for that.
Thank you very much for your presentation. I have a question related to what you mentioned. Of course, it's ideologically correct that supplier, OEMs, or each level should be equal partner. As we have seen over the many centuries now of automotive industries, that any kind of big recalls could not be reduced over the years, even by increasing the standards from basic manufacturing over ISO, VDA in Europe, QS 9000, IATF, and so on. The amount of claims and recalls are not reduced. And therefore, my question is not the cost always the same driver? You say you split the cost versus the quality, but at the end of the day, even your example of the Concorde, if that is not driven by poor maintenance, is maybe the cost. So the question is, how do you see today's OEM enabling a better quality through better cost allocation to the supply chain? Do you see that? Or, as I believe, it's exactly the opposite?
Okay, so I think to answer this question, we have to look one step ahead of OEM, right? OEM is driven by customers who end up buying the product. So it's all about the market and the market expectation for a given product segment that drives the BOM cost for a given product, which further boils down to the cost targets for your purchasing. So that's specifically the reason why I put out that 5 R's. Because when we talk about this 5 R's of purchasing, every component has got its equal importance. One component is never over the other. So that's first thing. Second thing, yes, field recalls or even if you take the NITSA database, there are recalls happening almost on every day. But one good thing that's emerging out of it is if you keep aside the software-based recalls and look at only the mechanical recalls that are happening, the trend has started to decrease in the last 10 years, if you look at the data points. So that shows us that in one of my slides that I was talking about the ICE versus the EV, the conventional supply chain is matured enough today to address all these rising claims and failures while the technology-based supply chain today is learning its curve. So the entire EV industry is on a learning curve. Never would have Tesla thought that they are going to go for a complete recall back in September 2023 for a simple antivirus software. And that was a turning point for every automotive industry where software recalls became more and more common. Even last week, Nissan has recalled a whole lot of bunch of EVs and even their own ICE vehicles for a software fix. So the third point, cost. I think I answered that question in the first half of my explanation. Cost is the driver. End of the day, all of us are in business. Nobody is going to do anything for charity. That's all it is. Thank you.
Thank you, Mr. Crockett. So that concludes this VidCast's presentation. If you have more questions, feel free to message or to approach Mr. Crockett. By the way, we will have a cocktail party, so if you have time, please stay. For the cocktail party at Venue 3, it's just on the same floor, so we can have a few drinks. All right, for the next speaker is from our business partner Temas Engineering JSC. The company specializes in collaborative robot, which combines a powerful and precise robot arm with native AI processing and smart vision system in a complete package ready for deployment in factories. He has years of experience as technician and sales engineer. Let's all listen to Mr. Nguyen Thu V. A round of applause, please.
Lời đầu tiên thì em xin gửi lời chào đến toàn bộ các anh chị cũng như là quý khách mời có mặt tại sự kiện ngày hôm nay. Em xin tự giới thiệu, em là Vĩ, phụ trách kinh doanh công ty cổ phần kỹ thuật Temas. Thì ở đây các anh chị cũng biết là ngành công nghiệp hóa tự động hóa ngày càng phát triển. Thì để làm sao để nâng cao cái năng suất lao động, cũng như là cái chất lượng của sản phẩm ngày càng tăng, thì và anh chị cũng ở đây cũng muốn là làm sao để là nâng cao được cái hiệu quả cũng như cái năng suất lao động của chính cái lĩnh vực của mình cũng như là cái doanh nghiệp của mình. Thì rất là vui, hôm nay rất là vinh dự thì em có mặt tại cái sự kiện này để chia sẻ cũng như là để trao đổi về cái chủ đề là tối đa hóa cái hiệu quả lĩnh vực sản xuất của ô tô xe máy bằng cobot là cobot Techman. Ok. Đầu tiên em xin điểm qua một cái gọi là cột mốc của lịch sử hình thành của robot Techman. Robot Techman thì được hình thành và phát triển bởi tập đoàn Quanta Storage. Tập đoàn Quanta Storage là tập đoàn chuyên về OEM trong lĩnh vực về máy tính như là HP hoặc là Apple, thì có trụ sở tại Đài Loan. Thì năm 2012 đến 2015 thì hãng có nghiên cứu và phát triển về robot. Thì năm 2015 thì cho ra mắt sản phẩm TM5 và ra mắt tại triển lãm IDEX của Nhật Bản. Năm 2016 đến 2018 thì Techman chính thức được thành lập và cho ra đời sản phẩm là TM5, TM12 và TM14. Và năm 2019 thì robot Techman thì mở cái văn phòng tại Shanghai, Trung Quốc, Hàn Quốc, Hà Lan và cũng cho ra đời cái ứng dụng là TM Palletizing. Năm 2020 đến 2023 thì robot Techman thì tập trung phát triển các cái ứng dụng liên quan đến TM 3D, cũng như là năm 2023 thì có ra mắt sản phẩm là TM Cobot AI S3D. Như các anh chị có thể nhìn thấy trên slide ạ, thì hiện tại Techman Robot có hơn 100 nhà phân phối cũng như là các cái đối tác trên toàn thế giới của nhiều các cái lĩnh vực khác nhau. Trong đó cái lĩnh vực về sản xuất ô tô xe máy thì đã có một số cái đối tác khá là lớn, ví dụ như Toyota, Honda, Hyundai hay là Ford. Các cái dòng model tiêu chuẩn của robot Techman thì robot Techman thì được cái giải làm việc khá là lớn và khá là rộng. Các anh chị có thể nhìn thấy đây, với cái dòng model nhỏ nhất là TM5700 với payload là 6 kg và sải tay là 700 mm, và cái model lớn nhất ở đây là TM25M với tải trọng 25 kg và sải đến 1,9 m. Thì với các cái ứng dụng tùy từng cái ứng dụng thì bên em có thể là tư vấn cũng như là các anh chị có thể sử dụng các cái model nó phù hợp với cái ứng dụng của mình. Ví dụ đối với các cái ứng dụng liên quan đến điện tử và bán dẫn hoặc là thực phẩm thì chúng ta có thể dùng dòng TM5. Dòng TM5 sẽ bao gồm hai model, đó là TM5700 và TM5900. Và đối với các cái ứng dụng liên quan đến gia công kim loại thì có thể mình dùng TM12 và TM14. Và với các ứng dụng có cái cần tải trọng lớn cũng như là cái sải tay lớn hơn thì chúng ta có thể dùng là TM20 và TM25M. Ngoài các model tiêu chuẩn đã bao gồm camera ở đây thì Techman có các cái option là có thể mình không có camera để mà phù hợp với các ứng dụng không cần thiết với camera, hoặc là với các cái ứng dụng kết hợp với AGV thì có dòng TM, có nghĩa là dùng nguồn cấp vào TM robot, đó là nguồn điện áp một chiều, có thể là tích hợp trên AGV và dùng nguồn của AGV luôn ạ. Trong năm 2023 thì robot Techman có cho ra đời dòng TM Cobot S-Series. Thì dòng này thì được nâng cấp lên với một số các cái đặc điểm nổi bật như tốc độ thì được nâng cấp lên 25, tăng tốc lên 25%, và độ chính xác đọc lại thì nâng lên là 0.3 mm, và các bộ bảo vệ của bộ điều khiển thì là 20 lên IP54. Cái thứ tư đó là phần tay dạy và teaching ạ, thì đã được nâng cấp lên cái màn hình hiển thị ở đây để chúng ta có thể là lập trình cũng như là mình thao tác nó tiện hơn, cũng như các cái tiêu chuẩn về an toàn được nâng cấp. Còn phần mềm TM Flow thì cũng thông minh hơn, an toàn hơn và sử dụng dễ dàng hơn. Đây cái hệ sinh thái của robot Techman. Thứ nhất là về TM Manager. TM Manager đó là phần mềm quản lý và giám sát thông minh. Phần TM Operator là sử dụng cho các ứng dụng chuyên dụng, ví dụ như là palletizing, packing, inspection hay là inspection hoặc là dispensing. Với các ứng dụng về application là chuyên sử dụng các phần mềm liên quan đến body vision hoặc là TM AI cộng. Và cuối cùng đó là TM Plug and Play là các cái phụ kiện đi kèm, ví dụ như các cái tay gắp hay cái áo bảo vệ trong các môi trường hóa chất hoặc là môi trường. Một số các đặc điểm nổi bật của robot Techman thì robot Techman thì được ứng dụng ở trong nhiều các cái lĩnh vực khác nhau, ví dụ như điện tử, thực phẩm, giáo dục, đặc biệt là ngành ô tô xe máy. Các ba cái keyword mà Techman đã làm nên nổi bật cái tính năng của robot Techman đó là smart, simple và safe, thông minh, đơn giản và an toàn, hay gọi tắt là 3S. Em xin giới thiệu chi tiết về S đầu tiên, đó là phần smart. Smart thì robot Techman thì đã được tích hợp camera. Ở đây là đã tích hợp camera 2D và camera màu và độ phân giải là 5 megapixel. Ngoài ra bộ điều khiển của robot Techman thì có tích hợp sẵn hai cái cổng kết nối với camera ngoài cho các cái ứng dụng liên quan đến cần độ chính xác cao hơn, hoặc là các cái ứng dụng khó. Đối với cái camera in-hand này thì chúng ta có thể sử dụng camera bên ngoài. Cái đặc điểm smart thứ hai đó là phần TMM mắt. TMM mắt nó là một cái tấm dáng nhỏ, nó là một cái gọi khác, nó là một cái gốc ảo để cho robot có thể làm việc một cách chính xác hơn. Các bạn anh chị có thể nhìn xem video được rõ hơn. Play video tí. Play video tí. Đây anh chị có thể nhìn thấy video. Đối với robot công nghiệp ấy, thì chúng ta phải định vị đến vị trí này để robot có thể là compute chính xác. Tuy nhiên đối với robot tech plan, mình có cái TMM mắt thì cái vị trí này mỗi một lần robot thao tác sẽ chụp cái vị trí này để lộ suy các cái vị trí compute để làm sao chính xác. Và TMM mắt này nó sẽ lộ suy theo ba góc là x, y và z. Nên khi chúng ta không chỉ xoay theo góc nghiêng, chúng ta có thể là cái chiều sâu trực z mình có thể thay đổi, mà robot chúng ta vẫn có thể là độ suy được cái góc để có bắt biết một cách chính xác. Đây chị có thể nhìn trên video. Cái app thứ hai đó là phần simple. Với robot tech man thì chúng ta có thể lập trình một cách rất là đơn giản. Có thể mình lập trình thao tác trực tiếp trên tay robot. Ở đây chúng ta có các nút ấn point để mà mình tạo cái điểm, sau đó robot chỉ việc lưu cái chương trình đấy và chạy theo đúng cái điểm mà mình mong muốn. Còn cái phần mềm giao diện phần mềm ấy, thì hiện tại phần mềm lập trình của robot tech man là VM Pro, dạng flowchart, thì mình chỉ việc kéo hạng từ bên thanh công cụ sang bên màn hình làm việc thì chúng ta có thể lập trình một cái chương trình rất là đơn giản. Như các bạn kỹ thuật ấy, để mà lập trình robot thì thường sẽ phải có một lưu đồ thuật toán trước. Còn đối với Techman thì mình đã vẽ lưu đồ thuật toán thì là đã xong cái phần chương trình rồi. Còn với lập trình thông thường thì sẽ phải vẽ lưu đồ thuật toán, sau đấy phải mình lập trình C rất là mất thời gian. Cái F cuối cùng đó là phần xếp, là liên quan phần an toàn. Thì để nói đến cobot thì không thể không nói đến an toàn. Thì hiện tại với cobot Techman thì đang theo tiêu chuẩn ISO 15066. Các bạn có thể xem video ở đây. Robot Techman làm việc thì tương tác với con người nên không cần rào chắn bảo vệ. Trong quá trình làm việc, trường hợp va chạm với người hay là các máy móc xung quanh thì robot sẽ dừng hoạt động và không làm ảnh hưởng. Toàn bộ cái phần khớp của robot Techman thì được có cao su và thiết kế dạng co tròn ergonomic để tránh trường hợp va chạm với người và gây tổn thương đến người và vật xung quanh. Như anh chị cũng biết là xu thế về công nghệ AI ngày càng phát triển, thì robot Techman cũng không thể không biết tới cái công nghệ AI này. Thì biết cái xu hướng của công nghệ AI thì robot Techman cũng có phát triển cái phần mềm gọi là AI cộng training server để giúp cho các cái nhà máy và các xu hướng của nhà máy hiện tại là smart factory cũng như các cái ứng dụng liên quan tích hợp với AI. Đây là một mô hình về AI cơ bản thì sẽ gồm có phần thu thập dữ liệu. Ở đây sẽ gồm có robot Techman cộng với camera AI để thu thập toàn bộ cái dữ liệu trên sản phẩm. Ví dụ như ở đây là cái mô hình sản xuất ô tô xe máy thì sẽ thu thập toàn bộ cái phần dữ liệu này, sau đó sẽ upload đẩy toàn bộ dữ liệu lên cái phần server, và người dùng đơn giản chỉ việc là đăng nhập và đưa các cái dữ liệu tiêu chuẩn của nhà máy vào đây. Sau đó cái phần server này sẽ so sánh và đưa ra các cái kết quả, ví dụ như OK hay NG theo đúng cái tiêu chuẩn của nhà máy ban đầu. Trên đây là một số cái video ứng dụng để phù hợp cho các cái nhà máy sản xuất ô tô xe máy. Đây là ứng dụng hàn. Hàn là một cái công đoạn ảnh hưởng đến sức lao động của con người rất là nhiều, môi trường độc hại và khắc nghiệt. Đối với robot hàn Techman thì có thể kết hợp với nhiều nguồn hàn khác nhau như ba ở đây. Và lập trình hàn của robot Techman rất đơn giản, mình chỉ cần xét điểm đầu và cái điểm cuối của vị trí hàn. Sau đó mình sẽ lắp thông số hàn ở trên màn hình. Đây các bạn có thể nhìn thấy một chương trình hàn của robot Techman rất là đơn giản. Thì cái ứng dụng hàn mà dùng robot thì nó sẽ luôn luôn đảm bảo được cái tốc độ cũng như cái chiều cao hàn, thì ảnh hưởng đến chất lượng của sản phẩm rất là tốt. Cái ứng dụng hàn tiếp theo, tuy nhiên là ứng dụng hàn này sẽ sử dụng với Prevision, Prevision. Đây là ứng dụng hàn, tuy nhiên là kết hợp với AHPM trong nhà máy, cũng như là một số các nhà máy liên quan đến Smart Factory đã là dùng khá là nhiều. Là AHPM sẽ đến lấy cái sản phẩm từ cái công đoạn trước hàn, sau đó đưa sản phẩm đến cái trạm hàn trong nhà máy. Đây là công nhân có thể là thao tác trong một số công đoạn chuẩn bị trước cho quá trình hàn, có thể là đặt dích gá sản phẩm lên AHP hoặc là đặt sản phẩm đây, đặt sản phẩm lên dích gá. Sau đó sẽ đưa tín hiệu cho AHP để đưa sản phẩm đến cái vị trí hàn mà mình mong muốn. Khi AHP đến vị trí hàn thì cái sai số của cái việc di chuyển của AHP là sẽ cao. Thì để đảm bảo được cái việc hàn độ chính xác của từng cái vị trí thì robot Techman như các em có giới thiệu đã có phần TMMax ở đây, là robot Techman sẽ chụp và lộ suy cái vị trí gốc này, sau đó lộ suy ra các vị trí điểm hàn, nên độ chính xác rất là cao và sẽ không ảnh hưởng đến quá trình sản xuất cũng như là NG sản phẩm. Đường hàn của robot thì khá là đều, nên cái độ bám chắc cũng như là ngấu sản phẩm nó sẽ tốt hơn. Đây, đường hàn khá là đẹp. Ứng dụng tiếp theo trong nhà máy đó là ứng dụng machine learning. Ứng dụng machine learning thì ở trong nhà máy sản xuất ô tô xe máy rất là nhiều. Các cái part tiêu chuẩn, các cái part trước khi lắp ráp thì đều được gia công bởi các máy phay, máy tiện. Thì để mà tự động hóa quá trình thì bắt buộc chúng ta phải sử dụng với robot để mà cấp phôi cho máy gia công. Đây như các bạn đã nhìn thấy là máy tiện đúng không? Với ứng dụng này thì robot Techman sẽ đứng im, còn cái việc cấp phôi có thể mình kết hợp với AHP hoặc là ở đây là công nhân có thể đẩy cái vị trí sản phẩm cho robot AGV, và trong quá trình thao tác thì robot AGV sẽ phải xác nhận lại cái vị trí của gốc phôi sản phẩm. Đây ví dụ như có tia mắt để xác nhận cái vị trí chính xác để gắp cũng như là thả sản phẩm sau khi gia công. Sau khi gia công xong trong công đoạn sản xuất thì sẽ tiếp theo đó là công đoạn về lắp ráp. Đây là công đoạn lắp ráp. Ứng dụng lắp ráp trong nhà máy thì rất là phổ biến. Như anh chị có nhìn thấy đây là mình là ship bit và được kiểm soát lực. Phần cài đặt thông số cho hệ thống phần vision cũng như là các cái hệ thống đo lực của phần đây. Trước khi thao tác thì robot tính man đều chụp cái tia ra mắt để định vị lại cái vị trí của sản phẩm, để tránh trường hợp khi mình thao tác sẽ bị va chạm với sản phẩm. Và toàn bộ cái công đoạn ship bit thì đều được kiểm soát lực qua cái đầu ship bit để đảm bảo cái việc lực được đều và chính xác. Đây ạ, cái bộ kiểm soát lực thì toàn bộ phần cấp bit sẽ được kiểm soát lực và có thể là sẽ đẩy lên server để làm sao kiểm soát được cái chất lượng của sản phẩm. Ứng dụng tiếp theo đó là liên quan đến mài và đánh bóng. Ứng dụng mài và đánh bóng thì của robotic kết hợp với robotic man khá dễ dàng, và kết hợp với force sensor để mà kiểm soát cái lực tì làm sao là mài được thẳng đều, và cái hai là không bị biến dạng của sản phẩm. Đây cái chương trình cũng rất là đơn giản. Anh chị có thể nhìn thấy khi mà mình tiết điểm cái vị trí mài, mình tiết trực tiếp ở trên robot khá là đơn giản. Đây điểm A, điểm B và điểm C. Đây cái chương trình này cũng rất là đơn giản, mình nhìn ở trên màn hình thấy luôn. Đấy, để lập trình một cái chương trình mài như này, các anh chị có thể nhìn thấy chỉ mất 1 đến 2 phút là mình có thể lập trình được rồi. Ngoài ra thì robotic man có thể kết hợp với các phần mềm mô phỏng và để làm sao giảm thiểu cái phần va chạm cũng như là phần lập trình cho các cái biên dạng phức tạp. Đây các anh chị có thể nhìn trên màn hình, mình mô phỏng một cái quá trình mài cũng như đánh bóng, sau đó mình xuất cái chương trình đấy cho robot để robot có thể là chạy theo đúng cái biên dạng mà mình mong muốn. Chứ còn để một cái biên dạng mà phức tạp như thế này, mình lập trình bằng tay cũng rất là mất thời gian và cái độ chính xác sẽ không được cao. Đây, với cái biên dạng bậc cao thì chúng ta sẽ phải dùng phần mềm để mô phỏng cái quá trình thao tác. Đây, mô phỏng cái quá trình thao tác để tránh va chạm, hoặc là nếu có va chạm hay là lỗi thì trên phần mềm đã có thể báo để là giảm thiểu cái rủi ro trong sản xuất. Và cái chương trình chạy này mình có thể là xuất ra và đẩy trực tiếp vào robot Techman để robot Techman là chạy đúng theo cái biên dạng này luôn. ứng dụng khác cũng là mài và đánh bóng. Đây anh chị có nhìn thấy cái biểu đồ lực khi mà robot Techman kết hợp với Force Sensor và cái ứng dụng mài đánh bóng trong ô tô. Đây, Force Sensor thì để kiểm soát cái lực tì giữa robot và cái góc cá của sản phẩm, để là làm sao đảm bảo được cái việc là mài lực đủ vừa lực của tất cả các vị trí, cũng như là để không làm ảnh hưởng đến các cái sản phẩm. Đây là một ứng dụng về TMAI Vision. Đây như lúc em có giới thiệu thì toàn bộ cái phần lấy thu thập dữ liệu thì sẽ là dùng robot Techman và kết hợp với camera để nhận biết toàn bộ, thu thập toàn bộ dữ liệu của phần xe, dụ như mặt hai bên thân này, đầu, mặt trước này, và có thể toàn bộ phần lắp ráp của phần động cơ xe. Và có thể là toàn bộ cái phần kiểm tra phần lắp ráp, phần nội thất bên trong của ô tô. Thì với ứng dụng này thì hiện tại là đang dùng với 6 robot để kiểm tra toàn bộ cái phần ngoại quan của cũng như là lắp ráp của phần robot của xe. Đây, và đẩy dữ liệu lên server để kiểm soát được cái data rồi, sau đó so sánh với cái yêu cầu của nhà máy để mình đưa ra các cái dữ liệu là ok hay gì. Và toàn bộ cái dữ liệu này có thể đẩy lên server để mà kiểm soát cũng như là truy xuất nguồn gốc sau này của sản phẩm. Trên đây là toàn các cái video và ứng dụng phù hợp với ngành sản xuất ô tô xe máy. Tuy nhiên thì nếu các anh các chị cần các cái yêu cầu cụ thể hoặc là cần các cái thông tin chi tiết hơn thì có thể là liên hệ với bên em để mà bên em có thể cung cấp các cái thông tin nó chi tiết hơn, cũng như là tư vấn các giải pháp nó phù hợp với cái ứng dụng của anh chị hơn. Em xin giới thiệu qua một chút về công ty bên em. Thì công ty em thì tên đầy đủ là công ty cổ phần kỹ thuật Tây Mát. Thì công ty em được thành lập là năm 2012, thì hiện tại thì quá trình hoạt động này cũng hơn 10 năm rồi. Thì bên em hiện tại đang có 3 cái văn phòng. Thứ nhất là văn phòng chính và xưởng thì ở hiện tại ở Hà Nội, còn một văn phòng ở thành phố Hồ Chí Minh. Thì hiện tại bên em tập trung đang là phân phối và nghiên cứu phát triển và các cái ứng dụng trong nhà máy công nghiệp cũng như là tích hợp hệ thống. Và hiện tại thì bên em đang là đối tác của 15 hãng trên toàn bộ thế giới, và Techman là một trong những cái hãng khá là quan trọng đối với bên em. Thì khách hàng chính của bên em hiện tại là 95% là khách hàng FDI tại Việt Nam, đầu tư tại Việt Nam, và 70% là khách hàng Nhật, và 20% là khách hàng Hàn, còn đâu là một số là khách hàng khác cũng như là các chế tạo máy trong nước. Cầu kết nối giữa robot Techman và thị trường Việt Nam ấy, thì hiện tại bên em đang tập trung vào hai cái tệp khách hàng chính, đó là chế tạo máy trong nước và end user là khách hàng dùng cuối. Đối với end user thì bên em thì sẽ toàn tư vấn từ giải pháp cũng như cung cấp toàn bộ thiết bị, vì hiện tại bên em có các bạn kỹ sư cơ điện cũng như lập trình PLC, PC để mà đủ đáp ứng được cái yêu cầu cũng như là tư vấn các giải pháp tốt nhất đến tay khách hàng. Còn đối với các bên chế tạo máy trong nước thì bên em cùng tư vấn cũng như là đưa ra các giải pháp hoặc là đào tạo để bên chế tạo máy có thể là đưa đến cái yêu cầu, đưa đến cái giải pháp tốt nhất cho phía nhà máy. Ngoài ra thì bên em có đào tạo cũng như là sửa chữa bảo dưỡng các cái thiết bị hoặc là các cái hạng mục mà bên em phân phối. Thì như các anh cũng biết là thực ra bên em không chỉ cung cấp riêng robot, thì bọn em sẽ cung cấp toàn bộ cái giải pháp kết hợp với các cái robot để đưa ra cho khách hàng cái máy phù hợp nhất với cái yêu cầu của phía khách hàng. Và bài giới thiệu của em đến đây là kết thúc. Em cảm ơn.
Thank you, Mr. B. Do we have questions for Mr. B? Anyone? Okay, no one. Now we pause for a 20-minute break. Let's enjoy the coffee break. And don't forget to visit the booths and say hello to our business partners. See you later.
I think you can try to pilot it on pilot operation.
Yeah, I have some picture and also some video where you can show you. Okay. Hiện giờ đang mass production rồi. Đây là sẽ chỉnh lời nó tính là nếu không mua thêm hai cái vấn đề quan trọng nhất là có để thay vì hai cái gần như là 5 cái do riêng em lo nấu nguyên
Hôm nay mới được gặp anh. Đi anh.
I have one video here, so you just need to.
Localized production, local supply chain. Company using the very simple software, very simple analysis tool. So it has to be
changes. Also, the more agile systems, in procurement, resourcing,
So we don't have the technology in that way. They knowing what the TV is, they want to design this and everything. And you can see, based on the camera, they also use the camera as communication. We have we are there what you put out we will invest, we will invest and so on. Yeah, but to invest is hard.
I think the economy is the state mandate. The state mandate is market demand, prevent fluctuation, much more flexible, I don't use strategies, strategies,
When a light beam is stimulated, it has infinite energy. Travel, explore, and discover the unknown. Along with the light, ahead of the times, leading the future of the industry. We shape our tool. Innovative appliance builds a brand new manufacturing system for corporations. From a chip to a beam of energy, we manifest the miracle of light. Cutting in a variety of forms. Molding any material. And breathing the beauty of light. We work on the finest details. Presenting you a new look. From intelligent equipment to innovation production line and smart factory. Our exploration is beyond light, around the infinite laser universe. Manufacturing contributes to intelligence. Innovation fuels a better world. Perceive the fineness. Feel the charm of science. Touch the void of imagination. We
We are HD Tech.1996年，大泽激光成立于深圳，是全球领先的激光加工装备解决方案提供商。2004年在深交所上市，股票代码0800。大泽激光全面服务于世界五百强企业和中国500以上工业企业。公司是国中级创新试点企业，坚持自主研发，满足全球不同客户对快速创新的追求。凭借在激光装备领域的雄厚实力，赢得全球客户的信任与合作。公司以实现长期销售，将提供智能制造集成方案的跨越发展，满足客户高效精准、快速增值的追求。公司拥有激光装备制造行业最敏锐和高效的研发潜力，生产制造和销售服务，实现激光技术与客户制造工艺需求的无缝对接。大为重启，专注力量，大泽激光。
have a peaceful life and your business will be very good. When wiping is stimulated, it has infinite energy. Travel, explore, and discover great more. Along the way, ahead of the times, we are the future of the industry. We shape our tool, innovating clients builds a brand new manufacturing system for corporations. From a chip to a beam of energy, we manifest the miracle of light, cutting in a variety of forms, welding any material, engraving the beauty of light. We work on the finest details, presenting you a new look. From intelligent equipment to innovation production line and smart factory, our expertise
Innovation is beyond mind, around the infinite laser universe. Manufacturing contributes to intelligence. Innovation fuels a better world. Perceive the fineness. Feel the charm of science. Touch the void of imagination. We are HT.走进大自然，科技之光无处不在。1996年，大族激光成立于深圳，是全球领先的激光加工装备解决方案提供商。2004年在深交所上市，股票代码0080008。大族激光全面服务于世界五百强企业和中国规模以上工业企业。公司是国家级创新实验企业，坚持自主研发，满足全球不同客户对快速创新的追求。凭借在激光装备领域的雄厚实力，赢得了全球客户的信任与合作。为自己实现长期销售，将提供智能制造集成方案的跨越发展，满足客户高效精准、快速增值的追求。公司拥有激光装备制造行业最敏锐和高效的研发潜力，生产制造和销售服务，实现激光技术与客户制造能力需求的无缝对接。大族传奇，专为力量，大族激光。
So we use the digital as a form of new communication. Because you learn how to teach the life and your business will be getting worse. Yes, sir. Local production, local supply chain. Supervisor or manually. Using the very simple sensor, very simple analysis tool. So
Hello, welcome back. Those who are still outside, please come here and we will resume with our session. We still have two more sessions to go, but before we wrap up the first day of the ASEAN High Performance Machining Summit, we hope that all of you have learned a lot from our previous speakers and have explored the possibility of connecting with other industry professionals as well. So now, let's move on to our next speaker from ShareTech, who will discuss the role of robotics and AI in achieving high-performance machining for auto parts and electronics in Vietnam. He had his master's at Keio University in Japan and became a scientific advisor in ShareTech before he became the research and development director. Let's welcome here on stage Mr. Wang Tian Dat. A round of applause, everyone.
Okay, so I think everything is already. So good afternoon, everybody, ladies and gentlemen. My name is Hoàng Tiến Đạt. I'm from Shatec company. So today is my honor to be here, and I will share with you about our topic related to robotics and AI. So first, that's in my agenda for my presentation. I divide my speech in the four parts. The first is robotics in the industry nowadays, and you will understand about the review information about the robotics on the world. And the second section, uh, I will share about the roles of AI when we combine them with the robotics. And finally, first one is the benefit of the AI robotics. And finally is the AI and robot in Vietnam. So first thing, you already got information from the previous presentation about the tech man, and everybody know about the robot. And now you can see surrounding us a lot of robot in the not only in the factories but also in the households or in the school. In the school, so why recently robot appeared more and more in the industries, of course, because it's bring their efficiency and more profit for the owner or for the organizer. So you can see by the number of the robotics nowadays, and you can see the number of robotics in different fields. And the automotive or electrical or electronics now that is more the largest of the robotics, and not only in the automotive but also in the electronics. The robotic can apply to many fields like fooding or transportation or chemical and some other field. And the number here you can see that's the unit is 1,000. And on the world now, based on the surveys, there is more than 3 million robots on the world now. Next, you can see here there are different reasons. Which reason now robots appear a lot? Not only in Europe, but also in America, is robotics is appear more in the Asia. So why is appear more in the Asia? Because you know the Asia countries now is a developing countries, and their automatic system is now is worth invest more and is need faster and is more smart. So that's why the robot can help them to improve their automatic system. And in Asia, of course, there's Vietnam. So that's why today I talk about the AI robotics in the auto part or electronics field in Vietnam. And for the investor, you can see the market side of the robot now. Just 4 years ago, the market size is just $2 billion. But until now, 2024, around 4 years, the size of the market increased more than 16 times. And based on the surveys and the prediction, in 2030, the market size can become predicted is just around 50, can be reached around $75 billion. So that is a good news for the investor and also for the company. So why and how the robot can more and more close to the human and more appear in the factories, and how we can develop the robotics more in the future to catch up the development of the industry 4.0. That's the solution here is AI. So what is the roles of AI in the industrial robotics? In the last presentation, you know that if the robotics man combined with the AI module or application, it can be smarter, can be predict and can be measured accurately and can do the task, the difficult task. So the role of AI is can help the robotics is more smart. So let's see the video and to understand how the AI can help the recently the traditional robot can be smarter. So please play for me the video. Thank you. So here is the like the PCB assembly process. So at the beginning, if when there is no other AI input to the robotics, it's have to do follow step by step the programmer before. But here, it's learn from their like expert or learn from their high technical, and then it can do again the same the human task. So let's see what they can do. So you can see this process and the activities look like it can be replaced for this part. So with the AI robot now, we don't need any the human in this step with the high precision that give detection and also it also can find the failure up when they assemble directly for the electronics part. So that's just a short video to show you with AI robot can help the human to just develop or to do one step in the electronics assembly part. So the question, what is AI and how the AI can combine with the robotic to make it more smarter and can be do rich like the human activities. So first, everybody I think know about AI. AI is just artificial intelligence, and in AI we have the machine learning, and deeply in the machine learning we have deep learning. So AI in general to help the machines have their like to imitate like human intelligence, and for the to make the robot is more smart, we can put more data and training. We give the data for the robot by the algorithm, and then it can automatically learn from the data. We just need to put the data. So that is the machine learning. And more and more in detail, in deeply, the deep learnings can like to make the robot is can thinking and can mimics like a human brain. So that is the most difficult. However, in the robotics now, I think the machine learning is can be until now the machine learning can apply to the robotics. For the deep learning is still a challenge at this moment. So here is some function I showed you about the AI or the machine learnings can be used for the robotics now. There is a lot of the function or the algorithm now, but here is the four popular algorithm of the AI or machine learning now can be applied or integrated for the robotics. The first can we say is ensemble algorithm. The second one is division tree, instant-based algorithm, and artificial neural network. So I think we often say the ANN or CNN. That is more popular and more familiar with the programmer or for the developer, AI developer. So I don't want to show the detail in each algorithm, but here it is the review of some of the AI algorithm using for robotics now. So, what is the benefit? Why we need to put the AI to the robotics? The first thing is automation. Without AI, the robots still okay, still work okay, right? But to some step still needs a human, still they need a human to stay with the robot or to control like the setting at the beginning, so the robot just follow them. But in some case, like we separate the fruit, we don't know which fruit is good and which fruit is not good. We need to train for a robotic to like our eyes to choose which one is good. So that step we should train for the robotics. And the second things, the robotics now is can separate or can choose the correct fruit or another thing. However, we want to make them more accuracy, like more than a human, because the human can do one time, 10 times still okay, but 10,000 times maybe we feel tired. So that's why we do maybe not correct. But robot, if we train them with AI, they do 10,000 and or more than 10,000 still have the same accuracy. So that's why the second thing is accuracy. And also the third one is adaptability. The robot with AI can work in the different environment for the different environment, like the dangerous environment, have the chemical environment is not good for the people. So that's why it can be trained to work in that environment. And also it can help the people or the worker to predict the error of their system. So that is the very, very advantage of the robot if we use AI. For example, in the system with the normal robot, they just work and they don't know when is error or they just know when error is happening. But with the AI robot, it can predict in early stage to reduce the dangerous case. So that is a very good idea, and now they already successful to do that. And the fifth one is making the decisions. It can replace the people to choose which is the right decision when they do in the like in the system. For example, you can see for the medical, right? The AI robots now can still predict the earlier stage of some disease. Uh, but however, it should learn from a lot of the data from the doctor. But that is one of the benefits when we input the AI to the robot, and also improve efficiency, increase the safety and cost reduction. That's another benefit of the AI robot. So when we integrate AI with the robotics, we can make the industry AI industries not only for the smart manufacturing, but also for smart marketing, smart operation, smart recycle, and smart designs. In each stage, we still can use the robot in each location here to make the circle to support each other to make the industry 4.0 more smarter. So here is one example of the AI robot in electronics factories. So as you see in the previous video, here is one of the robotics like universal robotics. This can help the human and work with the human to understand the environment, to make a decision, to perform autonomous action without the human, and also to do the automate task. Another factory is also can do like that. So as I said, it can increase profit. So in general, you can see this slide to understand clearly more how the AI and the robotic can help that system be more smarter and also to increase profit for the owner. You can see without the AI, the step or AI analysis here, we only have the left side for the cycle of the design processing or manufacturing processing. However, with the AI data analysis, we can get the data from, for example, from the material processing level, and then is feedback to the AI analysis step. Also for the machine process level and the system level, everything we combine data to this step. And then after that, the AI will analyze and give the advice to optimize the fabrication of the material to reduce the waste or to choose the good material properties, materials, and also to find the good condition for the maintenance and predict the maintenance. And then for the whole system, it can give a good modeling of performance analysis or make the advice for the planning scheduling. So that can combine together to make the whole system be smarter. However, the challenge when we combine AI is, I think, is still not easy, right? Because we have a robot now is okay, it's still good. However, we just to run alone and work for me, for us, without any control. So we need AI. However, it still needs a lot of things here. At first, we can see like the materials choosing selection, and also the power, energy, robust warm, and also navigation, and also the brain-computer interface, how they can understand more about the activities of the human to train for the human is still need a further researcher. So how about Vietnam? What we have until now with the robot and also for the AI, that is the question. Everybody know about the AIs recently and also the robotics. However, in Vietnam, it's still, if we compare to another Asia, in Southeast Asia, or in, like you can see Singapore, Malaysia, Indonesia, it still have their low speed to catch up. That's rare. So you can see this line, this that purple is shows the very high the catch up or very high adoption of the AI for each field. So in Vietnam, you can see it's still, if we compare to Singapore, Malaysia is still behind them. And also for challenging in the AI ecosystem in the data processing and also the database is still are the question. And that's why now is need more the investment for the robotics and also for the AI training for the engineer and also for their company to try to apply more the AI and the robot in the company. And here is this sixth sector, the AI robotics is work in Vietnam. I can make the review here for you. And first, for a technical center for the human resource, this also have the AI robotics now. And also for the financial sector and for detection. First in the agriculture and manufacturing and healthcare. So today we more focus on the manufacturing process. So I give you some example about the AI robotics. Now is applied in Vietnam. At first, for the Vinamilk company, they already have the robotics and they apply the AI here. What is AI robotics do help them in the factories? So you know they have a lot of warehouse and how to deliver and how to manage their warehouse is need a lot of the human force. So when they use their robotics, AI robotics here, everything is done automatically, and they can manage well and also deliver in the right location for the customer. And the second example is you can see in the Samsung company now. They already use the AI robot to try to detect the deflection of in their mobile phone automated system. And also they can use the robotic to optimize the process. When the robot work, they can learn from this process and then they can change, they can feedback to their user to try to optimize the system. And Next example is you can maybe we know about the VinFast. They have more than 1,200 robotics in their welding workshop to try to automatically weld their car frame, and they also already use applied AI here to optimize that process. However, you can see here is the apply of the robotics and AI in the big factories, right? So how about the medium and small and the medium company in Vietnam? How they can apply the robotics and also the AI in their company? So now there's one solution for them is a cobot. That is the one of the robot the Mr. V already is introduced to use. It's safer and it can work for the human and with with the cost it's cheaper than the bigger robotics in some factories as you see in the peers. And the cobot can work together with their safety operation, and also it can easy to apply the AI than the bigger robotics as you see in the webbing system. And that is the solution now. The settings is are introduced to our customer or there's requirement. And you can see some picture here also can show you is work with the human. That is the cobot or co-robot. And the first to is safe because when it's in the conflict with the human during the working, it can stop. Like you see the video from the previous slide. And after reviews about the information and also based on our customer feedback, I I know that in Vietnam, this still are challenging for applied AI robot in their factory. However, that is a big potentiality in Vietnam. So that's why we are trying to develop our robotics. Like you can see here is the universal robotics, and our engineer are trying to uh, input or integrated more their AI to the robotics to try to have the at first for the medium and a small SME company to do some small step first, and then we are trying to apply to the bigger company in the next stage. And another solution for we are giving for our customer is the robotics gripper. You can see here. That's we design to more flexible and more fit to the requirement of our customer. And another thing of the robotics is the motor. The motor is the heart of the robot. We are now develop the BLDC cobot. We are writing, we design the new mainboard to control the force and also to control the motion of the robot to try to more smart and safer during the working. So um, that is some review information of the AI robotics in Vietnam and also what we are doing for the robot for our customer. I just show you just a little bit information like this. So in conclusion, I can say that the AI robot will appear more in, I think, just in the 2 or 3 years in Vietnam. And I hope our solution can help for the customer or for the user more and more using the robots in their company and also in the for apply for in the more field, not only in the industrial field, but also in the another field like medical and also in the for education training. So thank you for the listening. That's in my presentation. Thank you.
Any questions for Mr. Dat? Anyone? None? Thank you, Mr. Dat. Our next speaker is from our partner association, Vietnam Association of Supporting Industries, or VASI. He will talk about ways to enhance quality control in auto parts manufacturing through monitoring machine performance. He is also the Smart Manufacturing Solutions Senior Consultant at Digiwin Software Vietnam joint stock company and has several research works published in prestigious journals by publishers such as Elsevier and Sage. Let's welcome Mr. Nguyen Suan Go. A round of applause, please.
Thank you very much, yes, for the introduction about my company and my. So our DigiWins have more than 40 years experience on digital transforming, and we have many brands in East Asia and Southeast Asia, and also in Vietnam too. And we have more than 5,000 customers all around the world. Also, before I also studied in Taiwan in manufacturing and management, and have a few years working with the manufacturing field. And now it's my pleasure to be here to share some information. And from previous presenter like Mr. Pravensa, right, and Hoàng Thiên Đạt, and also Mr. Beef, they said about the manufacturing and how the methods to enhance the product quality is from many perspectives. Some people focus on apply AI or apply some rule to promote and to create the value for enterprise. So from the perspectives on Dewin, we focus on management and manufacturing, and by many research results and in manufacturing, index is very important to enhancing your product quality is OEE. OEE is only the index, so what is the factor inside the OEE is very important. Maybe it's normal is IPQ, that's nice. However, to enhance to create the biggest efficiency producing a machine and increase the biggest performance, also lowest loss of progress, and also the loss of goods product. And that means you need to minimize your NZ alone. Yeah. So to solve this problem, to enhance your product quality is very important, because you're working in manufacturing that's working with 5M, right? You need to working with machine, with methods, with men, and men need to have a BT, need to receive the notice, and machine also is automated now, but it's very fast, and we about the management perspective also need to update. Yes. So that's you have the purpose first, and you need to have a method. Excuse me. Yes. Please help me back to. Yeah, that's one. And you have the index, and you have the methods, and also how to do this. Need integration. Yes, and also need into your basic data. Yeah. And before, after, inside, and after you producing product, you need to control all. Yeah. For most of okay here, I will tell a story. Let you know about like in a factory, if some senior worker he has most very last experience, but something before and before producing massive product, they need to start the machine. Also, they need to adjust the mode, adjust the feature, and also comply and standardize the activation. And from that, they need to control just not only adjust and control and maintain this activity for all the time in processing. So that's before we do something, we need to divide a long process to producing become to a small part, and we need to control some manufacturing parameter. We need to control well because if you are in factory and you out of factory will be different. Maybe the manager in there, the high senior worker will do it fast, but sometimes you're not there or they have some busy works. They will adjust the machine to run fast, and yes, the quality may be that problem. However, the quantity also relate to the volume customer needs. But for a long time, it's create many risks. Yeah, and not only the machine will attend to the manufacturing, also another machine and some measurement tool, yeah, also too. And in manufacturing, if your machine have some malfunction, you know about the situation, yes, and you need to make it urgent or you need to solve it on the right time. If not, you are working a person, he need to care many machine and not in here. But however, one problem happen in another machine. Maybe you come back the machine way. Maybe many defect problem already run out. Yeah. Uh, in manufacturing, so you need to know about the take time and the job unit per hour too. Yes. If you get on progress, it's no problem. But this index, if you cannot control, maybe you lose your progress because the machine not only produce this product, also the other process also needs us part. Uh, so this will affect how the manufacturing quantity, quality, and delay. Uh, Besides that, if you control the parameter of machine, but you're not there, so you can, if you use a tool, you can check the parameter if they access parameter, yes. And by the way, automatically send the information to your email or your mobile phone to control. No need some worker to report to you. It's too late. Yeah. And sometimes I have some sensor too. The machine not only working with his body and has some sensor to control some special product to ensure quality. Yeah. Like this, since the major acid, maybe some condition of knife or some material is too harsh or too short, we need to adjust to reach the biggest capacity for the machine. Yeah. And also buffer also is a weight because you refer an order, a customer needs you 5 days to deliver goods. However, you need 7 days because you don't know the progress, you don't know the situation of your machine. Yes, you don't know the status, so that you only can answer a customer or yes, you need 7 days. However, today you will waste. If one month you have 22 or you have 10 order, maybe you will lose 20 hour. Yes, 20 days. Sorry. And the machine also maybe for a long time will become old or not right way maintenance will become not right way and create to many defect products too. So for an example, the main speed of I think maybe need to 10 seconds to reach 3,000 rounds per minute. However, some problem come from the machine also not right way maintained and the ICs will be not right way running and the information will let us know to whether it's right time and into the time to maintain it. Yeah. Not only that, and some maintenance also about the feature, also the other also need to fix right time and right way by the fatigue way. Yeah. Before you produce a product, anything need to be okay. And also after you produce, or you finish your product, your most and your face, anything need to by most clean way and return your warehouse to protect. And the next time will create the good value, not by create many uh, defect for your product. Yeah. If you are agree with my idea and from the view enhancing your product quality to through maintaining your machine performance, maybe we will have some discuss and your factory here or your research here before any tool you have or you using is have the way to maintain the way to control your machine in a well condition to produce like the time, the running time of your machine by the color. Like here, this blue color is all this tool let us know how many machine we have and how many running, how many maintenance, and how many idle, how many time it has by fatigue way. Yes. And also, we know the capacity and the progress of each machine inside your tool. Yeah, maybe an app on your web or on your mobile phone or any equipment you have. Yeah. So you know the period we mentioned about that, job per hour or take time or cycle time and product output. Yes. And the other parameter we need to control too. Also, we have the analysis for all your machine about the efficiency, about the status, and you have some basic tool like petrol chart to analyze your machine, also your product quality. The petrol chart's basic logic is maybe is one of the tool to control the quality. However, it's very clear that you solve 20% of major problem, you will solve all 80% of your factory. Yeah. And also, we need to dashboards or we need controller to control your all equipment to reach your efficiency. Before you produce your product, you need to have a program or parameter exhaust. And inside producing, you need to control, and after you need to follow. Yeah, and have you by fatigue way to call up your previous parameter for same product or for the other new product and let it make library for the next time you produce. And also the final one is after you do both about the major factor like maximize your ability time and maximize your capacity, also minimize your loss of energy product. Your tool now also can provide or not provide analysis detail for the defect risk or any major problem, major reason for your producing products by the fatigue way and the right way. Maybe you do by manual, it's also okay now. But in 4.0 industrial channel. Also, you need to smart your factory by digital transform. Yes, this is my say from the view of you maximize your OEE to enhancing your quality reports. And researcher know, and you also know, a basic factory now all over the world only can reach 40 to 60% of OEE. But if you want to become 80% outstanding OEE to enhance quality product, you need to digital transform. Yeah. Thank you. Welcome any question.
Thank you, Mr. Paul. Do you have questions for Mr. Paul? Okay, thank you, Mr. Paul. And that's it. Please, if you have questions, feel free to approach all our speakers. They'd be happy to assist you or to answer all your queries. Do you have anything to say, Mr. Paul?
Nobody have question.
Thank you. Hello. Thank you very much. And we hope that you were inspired and learned a lot from the presentations of our speakers today. Tomorrow, we will have several interesting presentations, so don't miss our second day. Plus, we will have a factory visit at JK Vietnam Industrial Joint Stock Company. Registration will be on a first come first served basis, so those who are interested may go to the registration booth. We also invite you to the cocktails party later at Venue 3. It's just located beside this ballroom. It's also on the first floor of this hotel, and we will have a bit of relaxation to cut this productive day. Thank you, everyone, and see you again tomorrow. Take care.